For more information, please visit our website at DarkCyberetics.com. This is Dark Cybernetics, Mathematics for Computer Scientists. Distance formula. Follow our free course documentation. In this example, we have two particular points on the Cartesian plane. One goes below the line where we have, well, where the negative value starts. So we know this is, of course, the positive side, and below here is a negative one. So we can give this number a -1, and we can give this a 1. So we know that's 1. The number above it, of course, would also be 1. All right. To compute the distance for numbers who do not make parallel lines, we just need to simply know the absolute value of x2, of course, minus x1, right? Because they do not intersect the y-axis, we just need to know the x-axis. And we know, of course, we know if you do to take the absolute value of or square to x values or values that will produce a positive value. So we can simply, I guess, outline that this axis is the x-axis and the axis is the y-axis. And we just need to simply input the points. We put 1 here and 1 minus 1, 1 minus 1, if we learned from before. We add a plus sign here, so 1 plus 1 is 2, of course, so that's 2 actual units. So we know it's correct, right? We move 2 places over to get to the -1. We took the absolute value of this number, right? But for this other example here, we need to go about, since it's a diagonal, and we need to go about marking off the units on the plane. So we know that this is a 1, of course. If that's 1, this is 1, so we need to go up to it, and that's 3 points, 3 spaces over. And of course, this could be 3 spaces over the other way. All right. We know that if we use a distance formula, our distance between the points is the square. So we just put the points in here as 1 and 1 for one value, and we put the points in for this other region here. We suppose this is 3 and that's 3, so 3 and 3. All right. So since this is adjacent, it makes a diagonal line, we need to use a different formula to do this one, where we have x and y, and we subsection off the x and y axis. And we learned from doing addition and subtraction, the rules of integer multiplication, and we can do, there's a few laws we have to take advantage of to compute this. Since this is, of course, a right angle, right? We can use this formula where we take the square of x2, right? x2, right? Minus x1 minus x1, right? And we need to add that to the square, or to square this region. We need to make it, in case it was negative, we want it to be positive now. We add that value to x2 minus x1. Well, that's supposed to be an x. We need to fix that. Right. Okay. And we need to square that also. Alright, we need to plug and play this time. So we're going to say that D is equal to, what is our first input? It's a 3. Right? It's a 3 here. Alright. Minus, what is the other one, is a 1. And we need to square this portion. We need to add it to the value of the, of course, the corresponding numbers, which would be 3 and 1, -1 again, also would be -1, which is, there's no sign change this time. And we square it. All right, looking at doing the order of operations, P, M, E, D, well, the PEMDAS, or what I refer to it as, we need to do this would be 2 squared plus this number again here, 2 squared, and of course we do the exponent portion first, and then we would add the sums together. And so we know that we have the square root is equal to the square root of 4 plus 4, and we know that we'd have 4 plus 4 is 8. We would square root 8, and we would then in turn you get some approximate number for the distance. And for more information, please visit our website at DarkCyberetics.com.